Hi students, welcome to physics classes. Today we will discuss about class 11 chapter 3 motion in a straight line. In this chapter today we will discuss basic terms related to kinematics. Now in previous class we discussed about rest, motion and fixed points. Now to describe whether the body is in motion or rest, we need a surroundings, fixed surroundings. Now here it is more convenient for us if you describe the same in coordinate system, in rectangular coordinate system. Rectangular coordinate system means it consists of x-axis, y-axis, z-axis. Three are perpendicular to each other. These are mutually perpendicular to each other, and the intersection point we can name as O. This O is acts as a reference point. O is a reference point. Means it is a fixed object or fixed point. We discussed in the previous class, it is regarding motion. Object changing its position with respect to fixed point or fixed object. Now here instead of that we can take this reference point. This reference point is acts as a fixed object or fixed point. Here we can place a clock. Here we will place a clock to measure the time. We discussed the definition for motion in previous class. If the object changes its position with respect to fixed object or fixed point, now we are saying it is a reference point in a particular time. So to say time we need a clock. Now this coordinate system with clock, coordinate system with clock is known as frame of reference. Frame of reference. Coordinate system with clock is known as frame of reference. Now if one or more coordinates, if an object is changing, for example, if an object position changes means in coordinate system one axis changing or two axes are changing or three axes are changing. If one or more coordinates of an object changes with time, one or more coordinates of an object changes with time, then we can say the body is in motion. Coordinates in the sense x, y, z. If x-axis is changing or y-axis is changing or z-axis is changing or all of them changing, one or more coordinates of an object changes with time, then we can say the body is in motion. If one or more coordinates of the object, changes with time, then the body is said to be in motion. If it is not changes, if no coordinate is changing, then the body is said to be in rest. Here coordinates in the sense x, y, z. If any one of the coordinates of particular object is changes with time, then it is said to be in motion. If not changes, it is in rest. And if motion is one dimension, we can take only one axis. If motion is two dimension, we can take two axes. If motion is three dimension, we can take three axes. Means here we can take only x axis, here x, y axis, here x, y, z axis. Now here we are discussing about motion in straight line. So we can take only x-axis. Next, distance. Now if an object traveled from one place to another place, let us take A is a person who wants to reach his friend C by joining with others at B. Now here he wants to travel 4 kilometers and join with B, and both together will go to C 3 kilometers. Now he traveled from A to B and B to C. Now what is the length he traveled total from A to C? What is the length they travel? 4 plus 3, 7 kilometers. Irrespective of direction. Here, did we consider any direction? What is the path they have that they followed? Okay, now here, actual length of the path covered by the body is known as distance. Actual length of the path covered by the body is known as distance. Distance is the actual length of the path, or actual path length also we can say. Actual path length covered by the body is known as distance. Here we are not considering the direction. No need of direction here. Only length what they covered. Okay, that is, for example, A to B 4, B to C 3. So total A to C is 4 plus 3, 7 kilometers. No specified direction. So distance is a scalar quantity. Distance is a scalar quantity. Why scalar quantity? It is not having any specified direction. Not having any specified direction. So distance is a scalar quantity. Now in SI units, distance can be measured in meters, and CGS units, it can be measured in centimeters. Next, displacement. Now we will consider the same example as we taken previously. Now if a person traveling, like previous example only I am considering, from A to B 4 kilometers and B to C 3 kilometers they travel. Okay, now the length between initial point and the final point, the length between initial point and the final point is known as displacement. Length between initial point and final point A and C is known as displacement. Now this is from A to C. This is the displacement. Okay, or else here instead of this we can say shortest path between 2 points, or straight path between 2 points. Shortest path between 2 points or straight path between 2 points is known as displacement. Now what is the displacement here? How can we find the displacement here? By using Pythagoras theorem, we can find A to C length. Okay, now AC equal to square root of 4 square plus 3 square, opposite square plus adjacent square, 16 plus 9, 25, 5 meters, 5 kilometers. 5 kilometers is the displacement. Okay, now here you will get a doubt. Why sir is saying SI unit is meter and CGS unit is centimeter and using kilometers? This is other units. Other unit is kilometer only for practical purpose. But standard international units and CGS units are meters, centimeters. Even for displacement also, SI unit is meter, CGS unit is centimeter. Here we have direction. Here what we have? Direction. So as it is having direction, specified direction, displacement is a vector quantity. Displacement is a vector quantity. This is the direction. What is the direction? From A to C. You can explain displacement in another way also. For example, in motion along the straight line direction or one-dimensional motion, if a object, now the object is at P. It travel towards Y. Travel towards Y and reach to Q. Okay, now this is we can consider as an origin O. Now the position of object A when it is at P is x1. Now while coming into Q, A, object A position is x2. Now the magnitude of displacement is equal to final position x2 minus initial position x1. Now an object A is at a point P with respect to origin at a position x1 and Q at a when it is coming to Q at a position x2. So the displacement between P and Q, displacement between P and Q, so x2 minus x1, magnitude of displacement. Now what is the direction? Direction of displacement? Direction of displacement is the direction from initial point to final point. So P to Q, initial point to final point, that is the direction. That is the direction from P to Q is the direction, because in one dimensional motion it is moving in a straight path. So final point minus initial point is the displacement, and from initial point to final point is the direction. Displacement is a vector quantity because it is having both magnitude and direction. Now we can represent in vector notation. In vectors we discussed coordinate system, position vector. This is x-axis and y-axis. Now an object is at a point A and it travel in a different path like to B. Now what is the displacement between A to B? What is the displacement between A to B? This is the displacement. It is the displacement. Now position of point A, position of point A with respect to origin we can take R1, and position of B, position of B with respect to origin R2. So the displacement vector equal to final position vectors minus initial position, final position minus initial position. Like this we can represent. Now here we are discussing about straight line motion in one dimension. Now the relation between distance and displacement. Now if a body moving from one point to another point, for example A to B, let us take it is a number line 0, 1, 0, 10 meters, 20 meters, 30 meters, and B 40 meters we can take. Now from A to B travel. Now the distance equal to 40 meters. Displacement also 40 meters. Straight path. So in this case distance is equal to displacement. Suppose if it is written to this point C, A to B, B to C. Now in this situation distance equal to 50 meters, displacement A to C 30 meters. So distance is more than displacement. So finally from these two situations we can relate distance and displacement. Distance is greater than or equal to displacement. Distance is greater than or equal to displacement. Distance is greater than or equal to displacement. Now we have some situations. If distance becomes 0, body traveled from one point to another point. If distance becomes 0, what is its displacement? Displacement must be 0. If distance 0, displacement must be 0. Means here, if distance 0 means body not started its position, not changed its position, same point it is there, so displacement also 0. Now if in case if displacement equal to 0, displacement equal to 0, then what about distance? Here if displacement 0, distance may or may not be 0. Means if a body travel does not change its position, displacement 0, distance also 0. If body travel to some point and reach to initial position, displacement 0, but distance something is there, no? Take one example. If an object covers one complete circular path, what is its displacement? An object covers moving in a circular path, it completes one rotation. It completes one rotation. So started here, ended here. Now what is the displacement? So initial point, final point same, displacement equal to 0. Distance, if its radius is r, 2 pi r is the distance. 2 pi r is the distance. So whenever distance becomes 0, displacement must be 0. If displacement 0, distance may or may not be 0. You can take this example. Thank you for watching. Please subscribe for more updates.